If your testing process looks like this, change code, run program, reproduce behavior, fail, repeat, you're probably wasting hours of time. Today we will fix it. This is a game I'm building in the main series, but today we have a very specific task to do. Fix the camera so it doesn't leave the map boundaries. The first thing I want to fix is to stop camera movement if the camera X coordinate is less than 0, so the camera stays in bounds on the left side of the screen. Here is the camera class. The camera focus method has to be updated. The fix itself is easy. Let's test if it works. Now we have to spend about 10 seconds to check if the fix is actually working. It helped, but what if it didn't? Another quick fix and another wasted minute. And guess what? You have to repeat this every time you fix or refactor camera logic. There is a better way. I'm talking about unit testing. It's an automatic testing approach that allows you to test individual components in isolation. To make it work, we need a testing framework. There are several of the Python testing frameworks out there, but I will use pytest. First of all, let's install it. Now we are ready to write the first test. I will create a test package to keep my test together, and create a first test.py file inside the package. Pytest scans your projects for the file that starts from test underscore or ends with underscore test. Then it looks for the test prefix functions inside these files and executes them to evaluate if the test passed or not. Let's make tests that will fail and examine pytest out. The first section will show what file has been discovered by the pytest and test functions executed in each file. Dot mean test passed, f mean test failed. Second is the failures section, which shows tests that failed and specific assertions that has been failed. And then the summary information that shows how many tests are passed and how many failed. Okay, let's fix this test and move on. As you can see, the test passed. Cool. Now let's get back to the camera. I will place camera-related tests into the camera test.py file. And the first test will be the left boundary check, which I have already implemented. Tests themselves are usually following AAA structure: Arrange-Act-Assert. In our case, arrange means create camera class instance that we will be testing. The next step is to act, which means focus the camera outside the left boundary. And finally, assert that camera X coordinate will be 0 for this case. Run the test and you will see that pytest discovered the test and ran it, and the test itself passes. You may notice that I run pytest with the v flag, which increases output verbosity, and you can clearly see which tests were run. Okay, we confirmed that left boundary check is working. Let's do the same for the upper boundary. Test failed, because we do not have logic that limits camera vertical movement yet. So let's add it and test it once again. Now, without even running the game, I can be sure that camera stays inside the top boundary. Next to go are the right and bottom boundaries, but logic is a bit different here, since now we have to take into the account the camera size. Let's write the test and calculate the boundary logic down the road. To consider the camera is out of bound on the right side, camera X coordinate plus its width should be greater than the map width. To stay within the map, camera X coordinate has to be exactly map width minus camera width. If you have lost in these calculations, you can check my camera implementation video by the link in the video description. Test fails. So time to fix the camera logic. Rerun the test and now it's passed. Let me quickly implement the test and the logic for the bottom boundary and we will move forward. Okay, all tests are passed. Now we can check if the actual game is working properly. Everything is working as intended. But I'm sure you already know it since you have tested through it. The beauty of it is that you can do whatever you want with the camera class starting from this point. And you can always be sure that your logic is working, or to be aware if it's broken. Like, let's move the boundary check code in the helper function. And by running the tests you will know are you good or no. Test failed, because I forget to call boundaries check function. And now it works again. You can even move this code into another model, but having test will always tell you if your changes break something or not. Sure, I oversimplified the test and logic here, and real tests should test special cases, edge cases, and so on. But overall, the same principles apply. If your code tests your code, you have to worry less about optimization, refactoring, and growing your code base. I barely scratched the surface of the automatic testing in this video. But my point was to demystify the whole testing thing and show you that writing test is not a black magic, and actually easy to do. All you have to know is, well, programming language you are currently using. If you're interested in the testing topic, drop me a comment below this video. There is a ton of information left to cover. Do tests, write code, like the video, subscribe to the channel, and see you next time. Ciao!